the C3D. 3 weeks ago, so it's still brand new. It's got that new design smell on it, so you should go check it out. Before we get going tonight, I just going to ask you to kind of give me a second to ask you to take a moment of silence and reflection for the victims and the families of the 17 killed and at least 14 injured in yesterday's latest and worst school shooting, this time at Marjorie Stoneman Douglas High School in Parkland, Florida. So I'd just like to have a moment of silence and reflection for them. I appreciate it. Thank you. It's very exciting to be able to gather with folks who are choosing to come out and gather together in a moment of celebration and to learn something, which I think is wonderful. Tonight, it's my distinct pleasure to welcome you all to the second event of the 2018 UWF Hal Marcus College of Science and Engineering's Great Minds Distinguished Lecture Series. Tonight's esteemed speaker is Dr. Jyotika Virmani. Dr. Virmani is the Senior Director for Prize Operations for the Shell Ocean Discovery XPRIZE competition, which is part of the XPRIZE Planet and Environment Division. As you're going to hear tonight, XPRIZE describes their competitions as a highly leveraged, incentivized prize competitions that pushes the limit of what's possible to change the world for the better. The Shell Ocean Discovery XPRIZE is one of several active competitions launched to pursue bold and audacious goals that advance technological innovations in science, education, and health. Past XPRIZE competitions include the Northrop Grumman Lunar Lander X Challenge, the Progressive Automotive XPRIZE, and the Wendy Schmidt Ocean Health XPRIZE, for which Dr. Virmani was the Director of Technical Operations. The Shell Ocean Discovery XPRIZE is one of several ongoing XPRIZE competitions. It was established to engage research teams to design and build new, remotely operated vehicles and autonomous underwater vehicles capable of exploring the deep ocean floor, to develop ocean floor maps and provide images of biological, archaeological, and geological features. Currently, the Shell Ocean Discovery XPRIZE competition includes 19 international teams from across Europe, Asia, Africa, and North America. Before joining XPRIZE in 2014, Dr. Virmani served as the Associate Director of the Florida Institute of Oceanography and as a Senior Scientist at the UK Met Office, and as the Executive Director of the Florida Coastal Ocean Observing Systems Consortium, FCOOS. She earned a PhD in Physical Oceanography from the University of South Florida, an MS in Marine Environmental Science from SUNY Stony Brook, and a BSc in Physics from Imperial College London. Dr. Virmani is an Associate of the Royal College of Science and a Fellow of the Royal Meteorological Society, and I ask you to all join me in welcoming her to our stage tonight. Thank you very much.
Thank you. Thank you, Matt. Right, got to dodge the dodgy one here. So thank you all for coming out tonight, and it's a thrill to be here back in Florida and in Pensacola. So I'm going to talk about incentivizing technology development globally. And so as Matt said, I'm a senior director. I'm the senior director for the Planet and Environment domain at XPRIZE. So I have to say that may be the best job title I'm ever going to have, Senior Director of the Planet and Environment. I think the only step up is like, I don't know, intergalactic overlord of the universe or something. But let me see. Here we go. So for those of you who are not familiar with XPRIZE, we're a non-profit organization and we're based in Los Angeles, and we run large-scale competitions, multi-million-dollar global competitions to incentivize technology development. And through those competitions, we inspire the belief that we can create a better future. And our prizes, they, as I said, the means of doing this is through competitions and prizes, and our prizes drive radical breakthroughs that are for the benefit of humanity. But before I delve into those prizes, I just want to take a few steps back to about 150,000 years ago. So for most of our history as humans, We've evolved in a local and linear world. You walked to the next village. You knew about 100 people or less, those who were in the community that you lived in. It was a very slow, steady pace of life. But as you're all well aware now, we live in an exponential and global world. If you look on anyone's social media page, there's probably a few hundred people that they know. You can go from one place to another across the planet in almost next to no time. And so things are evolving really quickly. And it's evolving on an exponential scale. So what does exponential mean? So exponential growth looks different from linear growth. If you were to take 30 linear paces, you'd walk around 30 meters or so. However, I don't know how many, if you know how many paces, how far you would travel if you took 30 exponential paces. Does anyone know? And anyone who was here when I was going through the slides earlier is not allowed to say anything. You would actually go 26 times around the world. So by exponential, you're essentially doubling the distance that you travel in the previous step, okay? So that's that's the rate of change that technology is also working on. So to give you some examples, data storage. So in 1956, for data storage, a 5 megabyte drive would require a forklift and an aeroplane to move. It would cost $120,000, chump change for some, I'm sure, in the 1950s. Interestingly enough, that 5 megabyte drive would hold 6 of those photographs. So that's what storage capacity you had in the 1950s. And now you fast forward to 2016, you could get a 128 gigabyte drive for $40. And in 2017, I bought a 2 terabyte drive for around $100. So that's how fast the change is happening. It's not linear, it's exponential. So let's look at another example. Let's look at computers, okay? So currently, your average laptop or so operates at around 10 to the 11 calculations per second, which is around the speed that a mouse's brain works. The projection is that if you look at this exponential curve, in 15 years, your average laptop will operate at around 10 to the 16 calculations per second. That's the speed of a human brain. Add another 25 years to that, and you're looking at 10 to the 26 calculations per second. That's the brains of all the humans on the planet. That's how fast the computer power will be at your fingertips. So this is a really big shift we're in, this technology shift that we're in. It's a really interesting time in in our history, basically, to be here. So where does this kind of change apply? So it's applying in the areas of sensor technology. They're changing at a very rapid pace, artificial intelligence, and I know many of you at the University of Florida are working in this arena, actually. Robotics, synthetic biology, virtual reality. Have any of you had a chance to try virtual reality goggles or that experience? I see a hand or two. Amazing. What you see through those goggles versus a two-dimensional photograph is like night and day. It's incredible. 3D printing. So there's a whole host of areas where technology is changing on a very rapid scale. And so what we do at XPRIZE and what the technology competitions are designed for are really to pull these in to different arenas and to do that through prize competitions. And so through doing that, the goal, our massively transformative purpose at XPRIZE is to build a bridge to abundance for all. So by making technology more accessible, cheaper, you allow more people to participate. So now I want to take a step back and talk about prize competitions and why do we use prizes. That's our main mechanism of doing this, okay? So everyone is familiar with prizes. As children, you go for gold stars or the blue ribbon. As adults, if you're watching the Olympics, for example, we're rooting for those athletes. We thrill when they win an award, and if it's the team you're supporting, then you may go and have an extra beer if they don't win the award or the prize. So prizes and competitions, and we're not strangers to those. It's part of human psychology. And prizes for technology development have been around for a long time. So going back to the 1700s, the British government launched the Longitude Prize. And this was because the ships that they had, the sailing vessels of the time, were crashing into islands and rocks because they had no way of knowing the longitude. And back then, of course, astronomy was an astronomical type of... the navigation was an astronomical means. That's how you worked out where you were. So, of course, all the astronomers of the day figured out that this would be an astronomy problem. So the British government put up what would now be $4.2 million, the equivalent of. And it was actually, let me go back a second. It was actually won by a clockmaker, not an astronomer, in rural England. His name was John Harrison. It took him almost all of his life to convince the people running the competition that he'd actually won, but he invented the marine chronometer. He finally got his money. I think it took him 50 years. He got his money 2 years before he died. But he did get it, but most of all, he's best known for having invented the marine chronometer, which has led to navigation as we know it today. So that was a prize. Moving forward in history, in 1795, Napoleon needed to get food to his troops on the front lines, right? So he put up prize money, and this was for food preservation. And again, this was won by a Parisian, a candy maker, Nicolas Appert, who invented the process of canning. So the reason we have cans today is because of a prize competition. And so Appert is considered the father of canning, the canning process. Moving forward again to the 1900s, the early 1900s, again, there was a French hotelier this time who lived in New York, who wanted to get back to France faster than the sailing vessels of the day, which would take about a week, Raymond Ortigue. So, and I know we have a French gentleman in the audience, so I apologize for any mispronunciation of the names here. But Raymond Ortigue put up $25,000 back in the early 1900s, which is the equivalent of $290,000 in 2006. And that was for the first person who could fly across the Atlantic. It was established in 1919. It was finally won in 1926. 6 people died in the attempt to win this prize, and it was finally won in 1926 by an unknown maverick pilot from the U.S. Does anyone know his name? Yeah, Charles Lindbergh. So Lindbergh won that. He won it by getting rid of one of his engines and making the plane as light as he possibly could, basically on the premise that if he was going to die, he was going to die, and there's no point having an extra engine. So he won it. It made him a household name. But beyond that, what it did was kickstart the private aviation industry. So the reason I'm here today, because I flew in from Los Angeles, is because of a prize. The reason we have a private airline industry at all is this is what kickstarted it, and he flew on the Spirit of St. Louis. And in competing for that prize, teams spent over $400,000. So within 18 months, passenger traffic increased. Again, it really kick-started that private aviation industry. Number of aircraft increased. Aviation stock soared. So that was the impact from that competition. So that brings us to the modern era. So our founder, Peter Diamandis, grew up watching Star Trek, and he always wanted to go into space. But of course, space travel and going to space was the purview of government agencies such as NASA. And so his friend gave him the book, The Spirit of St. Louis. He read the book, and he thought, well, if this kick-started the private aircraft industry, why can't I kick-start the private spaceflight industry? And so in 1996, he launched the Ansari XPRIZE, and that was for private spaceflight. The goal there, it was a $10 million prize purse. The goal there was to have a fully privately funded spacecraft that could launch 3 people to 100 kilometers twice in 2 weeks. And the reason that it's 3 people is because it was looking forward at the market. A pilot, a co-pilot, and a paying passenger. So that was the goal there. It took 8 years for someone to win this competition. So in 2004, it was finally won, and so they won the $10 million. But what this competition has done has opened private space flight. So now it's in excess of $3 billion. So from 2004 to 2018, in 14 years, we now have a private spaceflight industry, and I'm sure you all know, Elon Musk's latest achievement, SpaceX's latest achievement last week. So the significance of this is huge, of course. It's hanging, if you go to the Smithsonian Air and Space Museum in Washington, it's hanging next to the Spirit of St. Louis. And you've made it when you're a Google Doodle, obviously. So it was a good competition, but that's also the competition that launched XPRIZE. I think I've covered this, so I'm going to move on. So XPRIZE, we've currently awarded $34 million in competitions, not just in the space arena, but and Matt alluded to some of these. The Progressive Automotive XPRIZE. We've had the Northrop Grumman Lunar Lander Challenge, which I'm going to talk a little bit more about. The Wendy Schmidt Oil Cleanup, Nokia Sensing, Ocean Health, and Tricorder. And these all cover different arenas. So it's not just space. We also have had prizes in the past on automotive industry. We've had them on environment. We've had them on medicine, on medical issues. We currently have $57 million in active prize competitions. The one I'm currently running is the Shell Ocean Discovery XPRIZE, which is a $7 million competition, which I'll talk about more in a little while. But we have prizes in education. We have the NRG COSIA Carbon XPRIZE that I'll mention. We have an IBM Watson Artificial Intelligence XPRIZE, a Women's Safety XPRIZE, so technology for women to address safety around the world for them, and then also water abundance. So can we get clean drinking water for everyone on this planet? So just to look at some of the prizes that we've launched in the past and have awarded. So the Progressive Automotive XPRIZE was a $10 million competition. I think it was launched around 2008, right on the cusp of when fuel efficiency was being discussed for cars, or was on the rise there. And the idea there was for 100 mile per gallon equivalent cars. So there were 136 teams from 11 countries that competed for this competition, and it was awarded in 2010, September of 2010. And I think some of the technologies that emerged from this are being used in some of the more fuel-efficient cars that we see on the roads today. The Qualcommtricorder XPrize. So who here is a Star Trek fan? Oh, good. There's a number. Great. So you all know what a tricorder is. For everyone else, a tricorder is essentially a handheld device from Star Trek that you can use to scan over someone, and it will tell you a number of different what's wrong with them, disease states, and what's wrong with them if they have a broken bone, etc. So the Qualcommtricorder XPrize is actually the development of that technology. So something that's ultimately handheld that you can scan, and you'll be able to, with no contact, say what's wrong with the person. So this was awarded in April of last year, so 2017. The winning technologies are around this big right now, and there is, you have to put little pads on your hands and things. So it's not totally non-contact at the moment, but that's the prototype. You can take it home. It will detect a number of different disease states, and I don't mean just take your temperature and pressure, but if you've had a stroke, if you have diabetes, just a whole host of things. Those technologies are under further development. But if you imagine back or think back to when telephones were big devices on the wall, and now we all have them in our pockets, this is the future of this technology. Right now, it's about this big, but in the future, I'm expecting something about this big that will say whether you've had a stroke or whether you need to go and see a doctor. So that's the Qualcommtricorder XPrize, which I think is very exciting. The Wendy Schmidt Oil Cleanup X Challenge, this was a $1.4 million prize purse. This was following the spill in the Gulf of Mexico that you're all more than aware of. And this was in recognition that the technology that was used to clean up that oil spill in 2010 was the same that was used for Exxon Valdez. There'd been no R&D really since that time. So Wendy Schmidt, who's the funder of this prize, and Peter got together and, discussed the situation, and they put up this prize. And it was a very short, this is our shortest XPRIZE at 15 months. So at 15 months, the bar that XPRIZE set, which was for cleaning up the oil 3 times faster and 75% oil-to-water separation, that bar was met and exceeded by 10 technologies. So in 15 months, you went from something that was not at that level to we have 10 of those. Amongst those were tattoo parlor artists from Las Vegas. So amongst those 10 final teams that exceeded that minimum bar that XPRIZE had set, you have a diversity of people. This tattoo parlor artist from Vegas, what I've heard is he was tattooing a businessman engineer, and they were lamenting over the oil spill, and they'd heard about this, and he had an idea. I assume it's based on oil from skin kind of cleanup. So they developed it, built a prototype, tested it in the bathtub, built a full-scale version, and they made it to the finals. We also had a fisherman from Alaska who went on the premise that if I can catch small fish, I can catch oil. He has a very great oil-to-water separation. So the ideas can come from anywhere. That's the point of these competitions. It doesn't have to be through people who know that industry inside out. If you have an idea, you can go for it. I joined XPRIZE with this competition, the Wendy Schmidt Ocean Health XPRIZE, which I was technical director for. This was a $2 million competition to develop sensors to detect ocean acidification. So we know that the climate is changing. We know it's changing the ocean, but we didn't have the pH sensor technology that you could leave in the deep sea or that could profile at very high at lab quality resolution in the ocean. And also along the coast. So this was split into 2 prizes, $1 million for the most accurate sensor and $1 million for the most affordable sensor that reached a certain level of accuracy. The same team entered 2 different entries to both of those pots and won. So the same team won $1.5 million. That team is from Montana, which is not known these days for its ocean environment. But what that did was showcase to the people of Montana that there is an ocean out there and that you can make money from it. So that was a great, outcome of this competition. However, also in this competition, we had university students. And I know there might be 1 or 2 here, so this is mostly as encouragement for you. So these guys were from Duke University, electrical engineering, mechanical engineering, and I think others in the team were computer sciences, as well as oceanography. So they all got together, they entered, they got to the semifinals, and they were undergraduates. Following this, the gentleman there on the left has gone to Woods Hole to do a PhD in ocean engineering. So that's the university students. We actually also had a high school student team who also made it to the semifinals. Their mum was their manager, so the mum manager. It was Jack and his friends from high school as well as his family, so the siblings down the line there, all took part in this competition. All of these students got to meet the world's experts in ocean acidification. They got to travel around. They took part in this global competition, so it really added to that. And Jack and his colleagues have gone on to Stanford University and to other universities, and we've written, letters for them to assist them. By the way, their device looked like a 1950s ray gun because they basically potted it in epoxy. So they put all the electronics in epoxy. It was fun. This shot is also from the Ocean Health XPRIZE. It's the finals. We were out for 6 days off Hawaii testing these entries. So what you see here is a device that collects water at different depths, a rosette, and then you have the 5 finalist entries that don't look so circular mounted on this so that we could measure the exact pH in a lab and compare it to what the entries had. One of the second place winners, they won $250,000. They gave their money away to an ocean observing program to make sure that there were global pH sensors out there on the Argo program. The other second place winner, the day of the award, they were walking around New York City wondering where they were going to get the funding to continue the company that they had set up to do this, because they were a startup company, because they were pretty sure they hadn't won. So it was a nice surprise for them, and they've continued as a company. So in addition to the ocean prizes, currently, I'm going to talk about some of our more active current prizes now, the Global Learning XPRIZE. This was actually partially funded by Elon Musk, but this is for the development of software on tablets to allow children to self-learn reading, writing, and arithmetic. So there's around 250 million children around the world that have no access to schools or teachers or adults who can help them. So this is being tested right now in Tanzania. The idea here is if you can raise the education level of children in a community, you raise the community. And by raising the community education level, you eliminate a number of other societal problems. So this is currently under test phase. We have the Barbara Bush Foundation Adult Literacy XPRIZE, and this is for a similar kind of thing for teaching adults in the US to learn to read and write. So these are people who've come here, they have a family, they're holding down 3 jobs. How do you teach someone who is so exhausted at the end of the day to take up something else and to learn to read and write, especially when their children are reading and writing ahead of them? So that's what this is addressing. The Carbon XPRIZE, this is the NRG COSIA Carbon XPRIZE. This is to, again, looking at the climate issues and the increasing CO2 in our atmosphere, is while we work out our energy and climate future, we need to take some action now. So this is to extract carbon dioxide from the atmosphere at power plants in the flue and to convert it into an economically valuable product. So the idea there is you're essentially showing some of the point source largest polluters that you're throwing money away. So make it into something of value. And then we come to the Shell Ocean Discovery XPRIZE, which is where I sit, and this is what I run. So as I said, it's a $7 million competition. $6 million is the main competition for mapping and imaging the deep sea. $1 million is from NOAA, the National Oceanic and Atmospheric Administration, and this is for something that we're nicknaming a smart sniffer, so something that can autonomously detect a biological or chemical signal underwater and then track it to its source with no human intervention. So it's a smart sniffer. It's a 3-year competition. We launched it in December of 2015. So we're going to conclude towards the end of this year or early next year. And the other big thing that we have pushed on this is there's no ships, no humans at sea. It's all robotics. It's all autonomous. The reason being that one of the reasons we do not have a good map of our seafloor is because it's super expensive to take ships out to sea to map the seafloor. It can cost $120,000 a day. And if you're sailing for 10 days before you start mapping, you've already dropped a ton of money, right? So we're removing the need for ships. So all of these have to go from the shore, whether it's by drone or on the sea surface or underwater. So we're really pushing on that autonomy front. So I want to play a short video for you, which will explain this a little better than I just did there, I'm sure. And this is something that we created when we were recruiting teams for this competition.
We humans are natural explorers. We can't help ourselves. Whether it's new worlds across treacherous landscapes or planets and galaxies beyond our imagination, the unknown calls to us, and we are driven to discover what's out there. But in all of our centuries of exploring, we've barely scratched the surface of one of the most fascinating places in the universe, our own ocean. It covers 2/3 of our planet, yet since the dawn of time, we've only explored 5% of it. Crushing pressures, extreme temperatures, and all-consuming darkness make exploration nearly impossible. The ocean remains the greatest mystery on Earth. What's going on down there? What discoveries await us? What new and fascinating forms of life will we find? The $7 million Shell Ocean Discovery XPRIZE is a global competition challenging teams to push the boundaries of existing ocean technologies and create safer, faster, and affordable ways of exploring the deep sea. This includes a $1 million bonus funded by NOAA for breakthroughs in chemical and biological sensors. By harnessing the power of autonomous underwater robotics, teams will illuminate the deep with high-resolution mapping and advanced imaging systems on a scale never seen before. The answers to some of humanity's oldest questions, or the cures to our most deadly diseases, could be waiting to be discovered. Imagine a future in which our ocean is healthy, valued, and understood. Be part of the discovery. Form a team or follow the competition online. The Shell Ocean Discovery XPRIZE, getting to the bottom of our ocean. Find out more at oceandiscovery.xprize.org.
So that was a video we developed during team recruitment, as I said. We're much further along, but some of the impacts that we want from this competition are to accelerate the technology. So if we use state-of-the-art technology today, that's in existence today, to map the seafloor at a very high resolution would cost around $3 billion and would take around 600 years. What we're aiming for is to have a high-resolution map by 2030 using some of this technology. So that's a huge push forward there. We want to catalyze new markets. So right now, the deep sea is for those who can afford to go out there. But by removing ships, you now open it up for others. So deep sea environmental management, deep sea conservation, or deep sea ecotourism, for example. And then another impact is to inspire the public. And this is because it is an alien planet. It's 4 kilometers away, but it's an alien planet. There are aliens down there. They've got 8 legs. They glow in the dark. They conduct electricity. They do all sorts of weird things, change color and camouflage themselves, and etc. So the ocean is an amazing place, but it is an alien planet. And so through that, we want to inspire the public because that's what they are with space. So why can't we try doing that with oceans? So starting on that track, our marketing department made a series of these posters just to tap into that whole idea. And as I said, so the prize we will award around end of this year, early next year, hopefully. When we launch an award prize, the day of the award, the final award is to us the beginning, because that's just the prototype development stage. And so beyond that, if you have a little more time, our goal is 10 years after that, we will, like I said, by around 2030, have a seafloor, high-resolution seafloor map. And just to give you an example of how little we know this, and I mentioned this earlier today in conversations, when they went looking for the Malaysian airline, they didn't find the airline. In fact, there's a new mission out right now looking for it. They found 2 new volcanoes instead, amongst a whole bunch of other things, one of which is bigger than Mount Vesuvius. So this is how little we know our own planet. We live here. We don't know it. So where are we in this timeline? We're actually about halfway through, maybe a bit more than halfway through. We are about to announce in March the finalist teams. We've had quite a journey to get to this point, actually. But let me go back to Last February of 2017, we announced 19 semi-finalist teams that Matt mentioned. They are from all over the world. The team members come from 25 countries. There are over 350 brains working on solving this problem at this point from around the world. 170 of those are students, from middle school to PhD. They're all students. And by the way, I should just point out, I don't know which the pointer is here. So this is from Duke University. Their approach is to use a drone to carry the pods out to the deep sea, to drop down, deploy the pods to map the seafloor. So that's a much easier, faster mechanism of transport. This group is from Japan. They have a number of autonomous underwater vehicles. This group is from Portugal, very similar. This group is the JEBCO NF alumni team. They're an international team that are affiliated with the Nippon Foundation. This is a team from Northern California. They're our youngest team, middle school students. They actually have had technology on the International Space Station, so this school has anyway. So they're very excited. And then this team is from Germany, and just for your benefit, their name is Argonauts. And I just found out today that the University of West Florida has Argonauts team. So if you're going to root for a team, I guess this would be it, the German team. So here are some of the technologies. We have autonomous vehicles. We have novel designs on the surface platform carriers to carry these vehicles out to sea. As I mentioned, we have drones. These are small, maybe 20, 30 centimeters. They're like marine bees using cell phone technology. And then we have different ways of mapping the seafloor. The traditional way is to do a lawnmower type pattern to do the map, but teams have actually come up with other ways of mapping the seafloor. So we'll see if that's more efficient. So let me talk a little bit about this competition. So our round one of testing was going to be in Puerto Rico from September to December of last year. As you know, there were a couple of hurricanes that hit Puerto Rico, and so we had to do a rather large pivot. Given the scale of an XPRIZE, this was quite an undertaking. So what we had already set up was we had a very high-resolution baseline map. The teams were going to come to us in Puerto Rico. They were going to map the same area. The judges would compare the great map we had to the maps the teams produced, and then we'd know who would move forward. Instead, we had to take a step back, and we have now just completed testing all the teams for their technology readiness level. So there are a number of different criteria that the judging panel are looking for regarding their technology. So instead of the teams coming to us, we ended up going to them. I've been on the road since just before Thanksgiving. I've been to 11 different countries, back and forth, Norway, India, Germany, you name it, to test these teams. And we are just wrapping up the judging process. So in March, we will be announcing who the finalists are. So if this talk had been slightly later, I may even have been able to tell you who the finalists are, but we're still working through that stage. So stay tuned for that, and that's coming soon to hopefully a newspaper or radio station or something near you. I also want to mention the XPRIZE Ocean Initiative. So this is a commitment that XPRIZE made to launch a series of ocean XPRIZes. And the idea is, collectively, that they would address our vision for the oceans, which is for a healthy, valued, and understood ocean. And the reason it's in that order is because in order to make something healthy, you have to value it. And to value it, you need to understand it. So the Shell Ocean Discovery XPRIZE, in a way, is a core piece of that. It's the understanding. When you land in a foreign place or go somewhere else, the first thing you do is look at a map. It's a core element of understanding where you are in the world. So we've had 3 competitions already, as I've mentioned, the oil cleanup, the ocean health, and ocean discovery. We're looking at what should be the next 2. And as I said, our overall goal is for healthy, valued, and understood oceans. In addition to the competitions of the technology development, we actually ran a side competition with our sister company, Hero X, for mobile app development using ocean data. So this came out of the Ocean Health XPRIZE. We recognize, if you have more sensors out there, you can have more data, but what do you do with all that data? So one thing we wanted to do was have apps that turn ocean data into products and services that anyone can use. So we just more or less wrapped up on this competition. It was $100,000 in a number of different areas for app development. Over there is listed a few of the finalists that were on the App Store. It ranges from visualizing ocean acidification to using your phone and being able to see what the bathymetry is like. So if you remove the water, what does the landform look like underneath the water? So there's a whole host of different things. And part of this, again, goes back and ties it to that business piece of this, right? So we're always also looking at the business side of this because the economy is part of what drives things. And so in the next 5 years, apps are going to be worth, $6.3 trillion, which is up $1.3 trillion from last year. So this is a big business, the app development portion. And so this is why, we kind of focused on this. But looking at other prizes, we are hoping this year to start work on a disaster prediction, whether it's in earthquakes or hurricanes. Can we improve potentially, and this is just for example, just to get you all thinking, can we improve the lead time on prediction by 10? So if you have a 1-minute earthquake warning, can it be a 10-minute? If you have a 1-day hurricane warning, can it be 10 days? So can we improve disaster prediction by 10? That would be my vision. I don't know what's actually going to happen with this, but I would like to have a disaster prediction XPRIZE. Another competition that we may be doing some initial work on is how will we nourish 9 billion people by 2050? Population is growing, so that's another area of potential interest. Of course, everyone's heard a lot about ocean plastics. To us, it's not so much about the cleanup side, which is crucial, but stopping it getting in there in the first place. As you increase the population, you're going to increase the waste. And so you need to put a stem to that to stop it getting in the first place. Looking outside the ocean realm, can machines help the elderly lead better lives? And I think the tour that I was given earlier today at the University of West Florida touches upon this kind of thing. Can nanobots search and destroy HIV cells or any other kind of cell, for example? Another potential example is we may have under development soon an ALS XPrize, so an Ironman XPrize. So for people who have ALS or Lou Gehrig's disease, where the brain is still active but the body is giving up, can we develop an exoskeleton suit that will integrate a number of different technologies to allow them to have better lives? And then the progression from there is for those who've had accidents or for the elderly. I personally would like cancer XPrize. So one of the issues for cancer is that you can cure 99% of cancers if you can catch them early enough. The problem is catching them early enough, right? In some parts of the world, there are no facilities. In other parts, it takes weeks to get results. You have to go into a hospital, use big clunking machines. The results are not always accurate. In the future, wouldn't it be great if you had something as simple as a mouthwash? You use it every day, it's cheap, it could change color, it tells you to go and see a doctor. So you can catch something early enough. So there are some really great things that I think, technology and advances can assist us with. So I'm going to leave you with this. What do you prize? So you can all think about what would you have to tackle if you had an opportunity. And with that, I'd like to thank you all. Thank you. And I'll take any questions if anyone has any.
Yeah, we have a mic for folks who might be interested in asking a question.
Just a bit about the mechanism. Do the teams submit proposals and then you fund them at intermediate stages?
The teams are all actually self-funded. So there are different ways they get funding. Some get sponsorship, of course. Some get funded by their entity. Some actually, the high school student team in Ocean Health crowdfunded their competition funds. And one of the other teams gave $1,000 to them through that crowdfunding mechanism, right, to encourage the kids to participate. So there are different mechanisms for getting funding. You can go, if you have a great idea, go to investors. There are people who will back this kind of stuff. So because you're there for you're there representing your hometown or your country or whatever the thing might be. So the teams fund themselves. The teams own their own intellectual property. So at the end of the day, if they want to set up their business, if they want to put it in a garage, if they want to sell it to someone else, that's their prerogative, whatever they want to do.
Great.
And we find a lot of them set up their own business. So from a competition, we will get 5 or 6 companies that emerge. So it really creates this field where there was very few companies and you could only buy the very expensive $30,000 machine from that one place because it's such a small market to there is now competition, and competition actually becomes healthy then in the marketplace.
Thank you.
As folks are thinking about other questions, I have one which is related to your previous slide about what do you prize. Can you describe the vetting process that goes into actually setting these prizes as they're moving forward?
Sure, yeah. So we actually have a 4-pillar structure at XPRIZE. The first one is more of a roadmap, impact map planning process for the future. So what's the future and how do we go from here to there? Which may include ideas for technology shifts. It may include policy shifts. And regarding policy, I should say that the Ansari XPRIZE, the private spaceflight one, we already had the space shuttle. I mean, the technology was not hugely new when that competition was going on. The big shift, the big impact was policy shift. That's what that competition did, was open the doors for private spaceflight. So it could be a policy shift that we either do through a prize mechanism or independently. So from that will emerge maybe 5 or 6 areas of potential change, right? And then from there it goes to the second pillar, where there is some prize design work that goes on. That gets vetted by our ecosystem, which includes global entrepreneurs and our board of trustees and others, people who have a global sense of what's going on and what we're about. So they really do a thorough vetting of those. And when they get the green light from that point and they get funded, that's how we move into prize stage.
There's a question up here.
Well, basically, my question was that are the steps where you lessen the herd, where you make your cuts, the same across most of the XPRIZes, concept, demonstratable concept, modeling, whatever? And what are typically, what are the typical cut downs, and where do you get your judges?
Great question. So they vary from prize to prize, the steps that are taken. So some will have a paper, like you submit what you're intending to do, the judging panel will look at that and decide if it's feasible or not. There's pros and cons to that, because some of these ideas are so far out there, it's hard to tell from paper if it's truly a breakthrough versus this is just a crazy idea, right? So that's a difficult one. It really comes down to the testing. So that's where I think the real cuts get made. I think at this point, most of them have a 2-step process on the down select there. For the Ocean Discovery XPRIZE, the first round of testing, which would have taken place in Puerto Rico, was to go down to 2,000-meter depth, map 100 square kilometers at 5-meter or higher resolution in 16 hours. The second round, which is what the teams will now have to do, is go to 4,000 meters depth, map 250 square kilometers at 5 meter or higher resolution in 24 hours. So we've really increased that level of difficulty for them. So each prize is different, but there are definite quantitative things that they have to overcome. And then the judging panel, so we have a science advisory board that we set up, and they actually pick the judging panel. So there's a level of independence from XPRIZE on the judging panel. And the names for the judging panel come from either the board or from us or from other people to say, well, this will be a good person to consider. And we have a certain set characteristics that you look for in a judging panel. Both collectively, you want to have broad expertise to address all areas of the competition. And then as far as characteristics of the people who are involved, you need them to be able to come to a consensus at some point. But also to stand their ground when, there's something clearly, obviously amiss there. So does that answer some of your questions?
So you're far beyond virtual modeling. You're actually demonstrating
Oh, yeah.
products.
No, not virtual modeling, very little paper. It's really, we have 3 years to go from zero to actual prototype technology that we've tested. Yeah, it's a push. Yeah.
Yeah, I don't need the mic. I think you can hear me.
Yeah?
It's that teacher voice.
Sure.
Awesome, very inspirational. I'm
Thank you.
excited about the future.
Great.
To your awareness, are there other countries around the world that offer similar XPRIZes? And are they redundant? Are they similar to some of the things that you offer?
Yeah, so great. Another good question. So XPRIZE kickstarted this again in the modern era. If you go back, kings and queens of old would do prizes. That was their mechanism. It wasn't grants through governments, etc. So in the 1990s, this kickstarted it. However, since then, there have been others, both within the US. There's now a lot more competitions that go on. Even the US government runs competitions at this point. And there are other countries where competitions go on. So for the 300th year anniversary of the original Longitude Prize, which was by the British government, there was the new Longitude Prize. So that was 2014, I think that was launched. And they are looking at antibacterial resistance. So I think that's what they're looking at. So we keep an eye on each other so that there is no duplication, right? So, and to give you an example of that, we were working on an ocean plastics prize, but there's another group, the Ellen MacArthur Foundation, that actually went ahead and we were working with them, and then things just didn't work out. They went ahead and launched a $2 million, two $1 million competitions. So we pulled back to see what the outcome of that competition is going to be. And then we will re-engage on that particular topic if we have to. But at this point, there are so many areas that can be tackled. I mean, the list is so long right now. You can take from science fiction, you can look around you, that there's room for a lot of competitions out there.
Thank you very much. It's really exciting.
Thank you.
I was curious how the teams divvy up the money.
That's up to the teams. So when we launch a competition, we set the rules right at the beginning. So for the ocean discovery, first place will get 4 million, second place will get 1 million. The finalists that we're announcing in March, they will divide 1 million between them in March. So any whatever the team structure is up to the teams working and get involved in that. So if it's a university and an industry partnership, it's up to them to figure out how it's divided. Or if it's and I'm going to talk about some of the more academic interactions we have. But if it's a two-person team, and we've had those as well, where it's like father and son, for example. It's up to them. that's the team to decide what they do with their intellectual property and what they do with their winnings and how they divide it. If they go on holiday, then that's up to them. Yeah, someone was mentioning lionfish, right? I think the University of West Florida is working. Yeah, I did see. I saw a video of the lionfish zapper, but I don't know if that's from the university or the people you were mentioning earlier. But yeah, lionfish. I've heard that's a huge. So that might be broadened. For example, this is how we would think, into an invasive species XPRIZE. So is there something that not just addresses lionfish here, but other invasive species? I have no idea what kind of approach that would take, but you can broaden it out, right? So yeah.
That's good.